to discuss about the definition of inductive reasoning. People in good moods are better at inductive reasoning and creative problem solving by Peter Salovey. And here are the definition of inductive reasoning. First, a logical thinking process in which multiple premises that are believed to be true are combined to draw a conclusion. The process of drawing a conclusion by observing a pattern in specific instances. This conclusion is called hypothesis or conjecture. It is a process of using examples and observations to reach a conclusion. And anytime you use a pattern to predict what will come next, you are using inductive reasoning. Three ways of inductive reasoning is used. Inductive reasoning is used in a number of different purposes. First, we use inductive reasoning in everyday life to build our understanding of the world. Second, inductive reasoning also underpins the scientific method. Scientists gather data through observation and experiment, make hypotheses based on that data, and then test those theories further. That middle step, making hypothesis, is an inductive inference, and they wouldn't get very far without it. And then third, finally, despite the potential for weak conclusions, an inductive is also argument is also the main type of reasoning in academic life. So the three ways of inductive reasoning used is first, everyday life, second, scientific method, and then third is academic life. And here are the examples of inductive reasoning. So inductive reasoning, using observed patterns especially. We have a steps. Step A, observe data. Step B, find a pattern. And then step C is make a conjecture. So, makikita naman po natin dyan. So, we need to explore that. So, in 1, 4, 7, 10, 3, 16, 19, dinagdagan lang po nila ng 3. So, yung 1 is maging 4. And then, ganun. And then, we need to follow a patterns. That's it. And inductive reasoning begins with a specific argument and arrives at a general logical conclusion.
Inductive reasoning is the act of making generalized conclusions based on specific scenarios. It is also the process using examples and observations to reach a conclusion.
This video, we're going to have inductive reasoning. So let me take first the definition of inductive reasoning. Inductive reasoning, it is the process of reaching a general conclusion by examining a specific example. So when you examine a list of numbers and predict the next number in the list according to some pattern you observe, you are using inductive reasoning.
See the example. 2, 4, 6, 8, 10, 12 blank. We are going to predict the next number by using inductive reasoning. To fill the blank or to predict the next number to 12. We can get the next number to 12 by finding each common difference. 2, 4, 6, 8, 10, 12, 14. The next number to 12 is 14 because its common difference is 2.
Inductive reasoning is a method of logical thinking that combines observation with experiential information to reach the conclusion. You can look at a specific set of data and form general conclusion based on existing knowledge from past experiences. You are using inductive reasoning.
Okay, we are done at the deductive reasoning definition. Let's proceed to deductive reasoning fact. Deductive reasoning, also deductive logic, is the process of reasoning from one or more statements to reach a logical conclusion. It is also goes in the same direction as that of the conditionals and linked premises with conclusions. What does logical conclusions mean? Logical result of the relationship between the premises as well as the premises. What exactly it means? A premises is a statement that is assumed to be true. Formal logic uses a set of premises and syllogism to arrive at the conclusions. We have 3 examples about deductive reasoning. Let's see.
Hello, this is deductive reasoning example. Refer to the figure given below and identify which of the following statements are correct. Number 1. Line A is parallel to line B. Number 2. Angle X is equals to angle Y. Number 3. Angle X plus angle Y is equals to 180 degree. Number 4. Angle X plus angle Z is equals to 180 degree. So, as per given data, angle X is present on both line A and line B. And that is, it is a corresponding angle. Since it is on the same side of the transversal line C, line A is parallel to line B. So the statement number 1 is true. Angle X and angle Y and form a pair of alternate angles. Hence, angle X is equals to angle Y. So the statement number 2 is true. If angle X is equals to angle Y, the only way for statement number 3 to be correct is when angle X is equals to 90 degree. Since that is not the case in the given figure, statement 3 is false. Angle X and angle Z form a linear pair. Their sum always equals 180 degree. Therefore, angle X plus angle Z is equals to 180 degree. So the statement number 4 is true.
If a number is divisible by 2, then it must be even. Okay, 12. So you can get any even number. So 12 is divisible by 2, and that is true. Therefore, 12 is an even number. If an angle A and angle B are supplementary angles, their sum is 180 degrees. So, if the measure of angle A is equal 100 degrees, then the measure of angle B is equal 80.
Problem solving is a mathematical process. As such, it is to be found in the strands of mathematical process along with logic, reasoning, and communication. This is the side of mathematics that enables us to use the skills in the wide variety of situations.
Facts and problem solving. Not all problems should be solved. Systems have problems when they go live. Self-service incident management does not make problems go away. The service desk may be missing or corrupting data critical solving problem. Every call to the service desk is a problem for someone. Thank you.
So, I have an example of problem solving. Like 15 plus 14 is equals to 5 plus 4 is equals to 9. 1 plus 2 is equals to 2. So 15 plus 14 is equals to 29. Another 15 times 25. 5 times 5 is equals to 25. Carry 2. And 5 times 1 is equals to 5. Plus 2 equals 7. And 2 times 5 is equals to 10. And carry 1. 2 times 1 is equals to 2. Plus 1 equals to 3. So, bring down 5, bring down 7, and 3. So, 15 times 25 is equals to 375. That's it.
A problem-solving strategy is a plan of action used to find a solution. Different strategies have different action plans. For example, a well-known strategy is trial and error. The old adage, if at first you don't succeed, try again, describe trial and error. In terms of your broken printer, for example, sabihin na natin, say you have a work deadline and you must mail a printer copy of report to your supervisor. By the end of business day, the report time sensitive and must be sent overnight. You finished the report last night, but your printer will not work today. What should you do? First, you need to identify the problem and then apply a strategy for solving the problem. You could try checking the ink levels, and if that doesn't work, you need check to make sure the paper tray isn't actually connected to your laptop. When using trial and error, you would continue to try different solutions until you solve your problem.
Problem-solving strategies. Many different strategies exist for solving problems. Typical strategies include trial error, applying algorithms, and using heuristic. So, what is trial error? What is trial and error? A trial and error approach to problem solving involves trying a number of a different solution and ruling out those that do not work. This approach can be a good option if you have a very limited numbers of options available. So, the applying algorithms is a step-by-step procedure that will always produce the correct solution. A mathematical formula is a good example of a problem-solving algorithm. And the heuristics. Heuristic is a mental rule of thumb strategy that may or may not work in certain situations. Unlike algorithms, heuristics do not always guarantee a correct solution. To solve a large complicated problem, it often always to break the problem into a smaller step than can be accomplished individually, leading an overall solution.
Hi, good day. My name is Jessica P. Almario from BSCD Section 1J. When you are presented with a problem, whether it is a complex mathematical problem or a broken printer, how do you solve it? Before finding a solution, to the problem. The problem must first be clearly identified, after that one of many problems, hopefully resulting in a solution. Method: trial and error. Description: continue trying different solutions until problem is solved. Example: starting phone, turning off Wi-Fi, turning off Bluetooth in order to determine why your phone is malfunctioning. Method: algorithm. Description: step-by-step problem-solving formula. Example: instruction manual for installing new software on your computer. Method: realistic. Description: general problem-solving framework.
Good day, I, Charlene Tibermas, grade leader of Group 2, Jump Continuity. So, we are done with the inductive reasoning, deductive reasoning, problem solving, and now we are going to discuss about problem solving strategies example. So, we have this example and problem solving strategy. First question is, the first week of math club had 3 students. The second week had 5 students. And the third week had 12 students. How many students will be showing up for the 8th week? So, today, I draw a diagram. I will discuss it so you can understand why I draw it here. So, I draw a diagram because it is continue from our problem solving. First week had 3 students. This is the number of the students and this is the week. The second week had 5 students. And the third week had 8 students. And the fourth week had 12 students. How many students will be showing up for the 8th week? So, if we look at the pattern, the first week and the second week, the pattern, 3 minus 5 is equals to 2. If you want to check the number, if you are correct the number, why it is come up with 2 number. So, you are going to 5 minus 3 is equals to 2. Same, that's a difference between 1 week and 2 weeks is the added grade 2 students. Same with the number 2 weeks and 3 weeks. The 5 minus 8 is equals to 3. So, 3 plus 5 is equals to 8. This they are adding of 1 number to every week of the math club. So, the question is, how many students will be showing up for the 8th week? So, I draw a 5 because in the 5th week, the students will add it with 1. Students will be going to 17 because I added with 5. It will going to 17. 12 minus 17 is equals to 5. So the 5 and 4 are a difference of number and the 5 is, and then the 6th week had 23 students. 6 added in the 6th week. And the 7th week had 30 students. And the question, for the 8th week, how many students will be showing up? So, we are look at the pattern, then we ended up with number 8. 30 plus 8 is equals to 38. That's the answer. The question is this. Why we come up ended up with the number 38? Because we are using a pattern to solve this problem. And I will have this one example too. We're going to the working backward. Example of working backward. How can we solve a working backward examples? So, I am thinking of my favorite number. I multiplied it by 3, subtracted with 6. From the product, added 5 to the difference, and divided the sum by 7. I ended up with number 5. What is my favorite number? So we are looking for the here or his favorite number. This we are going to come up with this number 5. So since we are going to work at backward, we are going to start from the favorite number of this question. We are going to work with the backward sum by the 7. We are known that the difference between divided is we are from the last number to find the favorite number. So we use add instead of divided. 5 times 7 is equals to 35. So is equals to 35. 5 I added 5 to the difference and I divided sum by 7. I ended up with a 5. So 35. And the 35 number, the answer to your question, the 35 number, we are going to, the question this is, I added 5 to the difference of the product. So the difference is 35. I added. He or she mentioned that he added it. So the difference of added is dash or addition. So we are going to use this problem. I added it to 5. 35 minus 5 is equals to 30. We are going to 30. The answer here, the difference in the number 5, the answer is 30. So I subtracted it with 6. He or she mentioned again that he or subtracted it with 6. And we are going to use again the difference of subtraction and addition. We are going to use today the addition. 30 with 30. The answer in your question, 30 plus 6 is equals to 36. Since he or she mentioned that we are going to subtract it, I used a different kind of problem solving strategies. So we are going to add it with 6. So the number is 36. And I multiplied it by 3. Since he or she mentioned that he multiplied it with 3, we are going to use the difference of multiplication. What's the difference of multiplication? And that's your right and your mind. We are going to use with 3 by 3. So she mentioned or he mentioned that she or he multiplied it by 3. So we are going to use this method to answer this. 36, 3 is equals to 12. So we are going to check the answer is 12 number is the favorite one. That's the answer, the 12. So now we are going to check it with the method of working backward. And now we are going to multiply. We are going to solve it with the top from top. I am thinking of my favorite number. What is he or she's favorite number? He is returning. It's a 12. So I multiplied it by 3. 12 multiplied with 3 is equals to 36. And subtracted it with 6. 36, the answer of 12 times 3 is equals to 36. Subtracted. 36 is equals to 30. 36 equals to 30. Where's the answer is 30. So from the product, the 30 product, from the product, I added it with 5. She or he added it with 5. 30 plus 5 is equals to 35. 35 to the difference and divided the sum by the 7. So he or she mentioned it that he divided the sum with this number 7. So we are going to 35 divided 7 is equals to 5. And I ended up with number 5. That's 5 is the correct answer for checking your answer from working backward of this to solve a problem. And the favorite number of the students who mentioned that he or she favorite number is 12. That's one of the example of problem-solving strategies. And now, we ended up with these examples. And we're done with the problem-solving strategies examples. Problem-solving examples to this to solve a problems is working backward, look for a pattern, look for a pattern, is working backward, yes and check, and draw a diagram, and look for a pattern. That's the example of problem-solving strategies to solve a problem. That's all. Thank you.